I didn't know collective noun for spectra was flocks. You learn something new every day. Orange light is 1 minute warning, and the green light is your 10-minute warning. Great. So yeah, I'd like to give you a quick overview of what we're doing from the perspective of what I hope are opportunities for the people in this audience, and then depending on time, I have some movies from IM2 I can show at the end, or I can show people afterwards. Next slide. Yep, so just the one slide on the company, because people in the audience may realize that we do more than just lunar landers. As shown on the left, there are really 3 pillars to the company. There's the delivery component, which is both orbital and lunar surface deliveries. There's the data transmission part, and there's also infrastructure as a service. Next slide. So we have won 4 of the, I think it's 10 task orders for surface deliveries as part of CLIPS. IM1 and 2 have already happened. IM3 is scheduled to go first part of next year, and then IM4 will go in 2027. And the takeaway from this is really that the goal for the company is to have a cadence of an annual cadence of the ability to take payloads to the lunar surface. As Paul mentioned, in 26 and 27 with IM3 and IM4, we will start to deliver communication relay satellites. And all 4 of these missions, the lander itself is a Nova C class lander, which uses our in-house built cryo-LOX methane propulsion system. Next slide. So as I mentioned at the beginning, that the company does more than just lunar landers, but this is meant to show sort of method of the madness. So you have the Nova C, as I mentioned, which will be the delivery provider for the 4 missions that we've won so far. The technology associated with this has allowed us to go into a broad range of additional directions. So I'll talk about some of these more in detail, but some of them, for example, the Nebula High Energy Orbital Transfer Vehicle. So if you take the landing legs off the Nova C and some of the landing systems, you end up with a high energy OTV. And so you can think of this as a proven 3rd stage for a Falcon 9. And in fact, we have a government customer for this nebula that it'll be flying in early 2028. We have Zephyr. We got some Texas money to develop an Earth entry vehicle. So this is aimed at the pharmaceutical and semiconductor manufacturing world. And so this will go into low Earth orbit for a certain number of weeks or months, do the manufacturing, bring it back, and then rinse and repeat. And the others I actually have a slide on. So next slide. So we have Moonracer. We're one of the 3 teams down selected to provide the unpressurized rover for crew. This is where we are prime. You can see in the top we've got some very good industry partners. We would deliver this to the moon using a Nova D. So the Nova D is the next sort of step in the lander development. The Nova D can deliver up to about 2,500 kilograms to the lunar surface. The Moonracer would be operated out of Nova Control in Houston and use our lunar data network comms system. Next slide. So the Hopper was developed as part of the NASA's STMD Technology Mission Directorate. Think it's a roughly 1 meter tall monoprop sort of regional transportation system. It can carry about 8 kilograms, multiple kilometers. It can fly anything from parabolas, which are obviously the most efficient from getting from A to B, but it can also fly a constant altitude traverse. The idea is to do extreme access, it's complementary to rovers. It's when you need to go somewhere quickly or to access something like the floor of an impact crater where the walls wouldn't allow the rover to go. And we certainly hope it will be allowed to be part of PRISM 4 as one of the mobility solutions that could be requested. Next slide. So we are looking at survive the night capability. We know that the science community wants it. At this low-end scale, we have this RPS system. It uses americium instead of plutonium, which has benefits from a handling and manufacturing perspective. We've got a system design that weighs about 40 kilograms and produces about 140 watts of electrical power and about 300 watts of heat, which is also useful on the moon. Next slide. So when we first started as a CLIPS company, NASA said you cannot rely on using DSN. And we took that literally and said, right, we're not going to use DSN at all. Whereas in fact, what they meant was you can't assume, you have to ask. But by the time we realized that, we already had a system in place. And so we have contracts around the world with radio science dishes. Most of them do uplink and downlink. Some, like Parks, can only do downlink. They range in size anywhere from 20 to 64 meters. And so we use those rather than DSN when we do a lander mission. The Lunar Data Network refers to our entire architecture. So that's the ground station portion. We're also putting up the communication relay satellites. Again, the first one will fly next year. LDNS 2 and 3 will fly on IM4, and then 2 more will follow. What was new with IM2 over IM1 is previously doing orbital determination for a spacecraft leaving Earth was the purview purely of DSN. We wanted to develop an in-house capability to do that and not need DSN for orbit determination. So for IM2, we did our own orbit determination for the lander, so working out what its trajectory was so we could plan the TCM maneuvers on the way to the moon, as well as the lunar orbit insertion burn. For IM2, we used DSN because it's really good as a test, so that we could compare our OD solution with DSN. But basically what we've learned after IM2 is that we do have the capability to offer that either for ourselves or others to do orbit determination for your vehicle that is heading out away from the Earth. Next slide. So coming up, we have IM3 next year. So the original task order, which is what's listed here as NASA payloads, we have a laser reflector from the European Space Agency built in Italy. This is one that can be lased from Earth. It has a pointing mechanism. We have LUSM, a charged particle detector from the Korean Space Agency. Cadre will test rover swarm capability from JPL. And then we have the Applied Physics Lab's Lunar Vertex. So IM3 is going to go to Rhino Gamma magnetic anomaly. We also have several commercial payloads, and that's another takeaway of CLIPS, is that CLIPS was initiated to see if there was a commercial payload market, and we've certainly found that there is. On all 4 of our surface delivery missions, we have roughly an equal number of commercial payloads and the original sort of task order payloads. Next slide. As Paul touched upon, LDNS-1 is going to go next year as well with IM3, and we have decided to use that as an opportunity to start to get new remote sensing data sets. So we're going to fly 4 instruments on LDNS-1. We have high tide shown there. We have a multispectral camera out of Poland. Or two. Wow, that's so lucky. And that will sort of redo the Clementine multispectral bands. We are flying the flight spare of Crater, the radiation experiment for University of New Hampshire, and we're also looking at flying some small HD video cameras. Next slide. Yeah, then IM4 in 2027, the NASA task order, again at the top. Prospect from the European Space Agency will be the most capable ISRU experiment that will have been flown, and then there are others that you can read there, as well as commercial, and 2 more LDNS satellites. Next slide. So very quickly, the opportunity for this audience is we can provide rideshare of different kinds. You can simply get a TLI throw. You could be dropped off in lunar orbit, in a 100-kilometer circular orbit before the lander lands, as well as be dropped off from the communication satellites. You could be a hosted payload on LDNS or on a small dedicated orbiter. There's obviously the taking payloads to the surface. We're looking at survive the night capability, as well as putting in cislunar infrastructure such as COM relay and LTV. And on the LTV, we have a trailer system so that we can design bespoke trailers to do the science that you want to do, which can have a significant amount of payload power capability. And next slide. Keep going, next one, because I'm basically done. I'm going to show you one movie. Next one. Next one. Next one. Oh, no. Next one. I want to show you Shackleton from 100 kilometers. Next one. Yeah, press play on this one, please. And you'll see this is during the lunar orbit stage of IM2 when we're in a 100-kilometer circular orbit. And he says, as we head to the Terminator, you can see Shackleton going underneath, and you're thinking, oh, we're going to land there. And as I haven't been dragged off yet, show the next movie, then I'll be done. The next movie is taken by the two PAO cameras just stitched together, and they show the final descent, and you're finished with the final pitch over. And I'm happy to talk with anyone offline. I'm happy to talk more about IM2, but the purpose of this story today was more to show you the opportunities. And thank you.